So you can actually split the amount and gamble multiple times. Okay, or you can just gamble the entire amount the same time. So that's also comparison between the two gambles. It's like, if I gamble, I mean, let's say if I play this 2 times, it gives me 1 with probability half, 0 with probability half. If I play this 2 times, okay, then then basically I'm going to get 2 with probability 1/4. Okay, right? Because I'm playing this 2 times. Okay, I'll get 2 with probability 1/4, 1 with probability half, and 0 with probability 1/4. Right? It's a binomial random variable, sum of the lotteries. Okay. The other possibility is I also have an option to gamble the entire amount straight away. So basically, I can just play straight away for twice this much. So that means 2-0 with half probability. Okay, so it's again, it boils down to comparison between two lotteries. So if you actually check, a risk-averse individual would like to actually split the amount and play multiple times, then play the entire amount on the first gamble. Okay, the reason is because if you just think about this, this is 2-0, 2 with probability half, 0 with probability half. You can show that every concave utility function will prefer this lottery to this lottery, even though the expected value is the same. But you can prove that every concave utility function will prefer this lottery to this lottery, and in fact every risk-loving individual will prefer this lottery to this lottery. Anyways, let's just quickly prove, now that we have gone to this particular point. Let's quickly prove. So basically, the lottery is like this, that you have an option to gamble the full amount straight away, like basically take a full lottery straight away, which is going to give you the total amount with half probability, and 0 with half probability. The other possibility is whatever the total amount is, you can split it into two lotteries. So you can say that I'll take, for 1 rupee, I'll gamble first, and then for another rupee I'll gamble again. So that will give you this kind of a lottery. Let's show that a risk-averse individual will always basically weakly prefers this lottery to this lottery. Let's show this. Okay, so what is the satisfaction level? Let's call this X, let's call this Y. Okay, what is the satisfaction level associated with X? It is 1/4 U2 plus half U1, right, plus 1/4 U0, right? Yes or no? Okay, that's the utility associated with this lot. Do you agree? Okay, now what I'll do is the following. By the way, do you agree U1 is greater than or equal to half of U2 plus half of U0? Why is this true? Because U is concave, so this is true. So because 1 is the expected value of this lottery. Do you agree? So 1 is the expected value of this lottery. So individual will always, because it's a risk-averse individual, will always prefer 1 over the lottery itself. That's this inequality. Yeah. So this is the utility associated with the expected value, and that's greater than or equal to expected utility of the lottery. Yes. Okay. So if I replace this by half U2 and half U0, do you agree I'll make this term smaller?
Yes.
What is the right hand side now? What is this? Basically, what is this side of the inequality? 1/4 U2 plus 1/4 U2 is half U2, and 1/4 U0 plus 1/4 U0 is half U0. Yes or no? And this is what? Capital U of Y. And U of X is greater than or equal to U of Y if the individual is risk averse. That's the proof. Have you all understood this? Okay.